Good morning, girls. We are going to continue the exercise 8.1, and you know that in the yesterday's video I had explained you question number 1 and question number 2 from the exercise 8.1. Now today I will take over two more questions 3 and 4, and they are little lengthy questions, children. The whole question is based on the entire proof, so you have to pay attention very carefully. So when you are seeing my video, see that you don't lose your connectivity and understand the question carefully. Still, if you have any doubt, you can ask me. Question number 3 says that if the diagonals of the quadrilateral are bisecting each other at right angles, then it is a rhombus. So I repeat the question that if in a if in a quadrilateral, okay, if this is a quadrilateral ABCD, the diagonals are bisecting each other they are meeting at O firstly, and then you have to prove that this is a rhombus if they bisect each other at right angles. Okay, so you can understand the question once again. You can read that if the diagonals of the quadrilateral bisect each other at right angles, then it is a rhombus. Now children, to prove that it is a rhombus, we have to show that all the four sides in a rhombus are equal. This property you have studied in your previous class. Now we will consider the two triangles in such a way that we will first prove that ABCD is a parallelogram. Okay, when we will prove that it is a parallelogram, we will get the opposite sides to be equal and parallel. Okay, then in the second part of the proof, we will then take up two triangles in such a way that we will get adjacent sides to be equal. Did you follow what I am saying? Okay, now listen and pay attention. The given points are that ABCD is a quadrilateral. Yes, it is a quadrilateral. Now they are bisecting each other, so therefore OA is equal to OC and OB is equal to OD, right? And the next part is they are bisecting each other at right angles, means AOB is equal to BOC is equal to angle COD is equal to angle DOA, and all the four angles are equal to 90 degree. This is given. Now we have to prove, as I told you, we have to prove that ABCD is a rhombus. Now how it is a rhombus? Only when all the four sides are equal. So this is what we have to prove. So to prove that all the four sides are equal, we cannot prove them directly. We will first prove that ABCD is a parallelogram. So let us consider the two triangles starting with the proof. Okay, now in triangles. Now which two triangles should we consider? I will take BOC and AOD. These two triangles I will take. So triangle AOD and triangle BOC. Now first point. OA is equal to OC given. Then number 2. OB is equal, OD is equal to OB. Yes, OA is equal to, we are considering which two triangles? This and this. Okay, so when you consider these two triangles, OA is equal to OC and OB is equal to OD. Okay, this is also given. Now what is a third point you can take? What is the third point you can take? This angle and this angle, these two angles are 90 degree. Okay, so angle AOD is equal to angle BOC equals to 90 degree, which is given that the diagonals bisect each other at right angles. Then triangle AOD is congruent to triangle BOC, right? Now yes, now when I prove that they are congruent, we can now write that this angle, okay, this angle will be equal to this angle. Can you tell me which angles are these? These two are alternate interior angles. Similarly, I can also write that this angle is equal to this angle. Yes, when the triangles are congruent, their corresponding parts are equal. So we can now write any one part we can consider, or any one angle we can consider, and say that OAD, angle OAD is equal to angle OCB, yes, which is alternate interior angles, and why they are equal? By CPCT. Now since the alternate interior angles, either this pair you take or this pair you take, alternate interior angles are what? Equal. Therefore we can now write that AD is parallel to BC. Yes, AD is parallel to BC. Now similarly, as I told you that we are proving this ABCD to be a parallelogram. Now similarly we can prove that AB is parallel to CD. We can show the proof, or we can write by considering which triangles? AOB and COD. Now since AD, we can now write, since AD is parallel to BC and AB is parallel to CD, therefore what? ABCD is a parallelogram. Yes, now ABCD is a parallelogram. Okay, now one part complete. Now I will take two triangles in such a way that I will prove that the adjacent sides are equal, and then we will prove all the four sides to be equal. Now you know that ABCD is a parallelogram, therefore AB is equal to CD, yes, and what? AD is equal to BC. Now these two parts we will consider in the next part of the proof. Now let us take the two triangles. Triangle, which one? We can take triangle AOB and triangle, which one? BOC. Okay. Now AOB and BOC. You can say that OB is equal to OB common, right? Then yeah, AOB, angle AOB is equal to angle BOC is equal to 90 degree, which is given. Yes, and what? It is a quadrilateral. So let me check out this triangle in which I have taken OB and this one, this triangle. So I have taken OB as one. Then I have taken, yes, I now take the third point as OA is equal to OC, because this is given, and we can say that diagonals are bisecting each other. Okay, so I hope this part is clear to you. You can see now what I have written. Okay, now the two triangles AOB and BOC are congruent to each other. Yes. Now I will now rub this part, and in the second part of the proof we now write the triangles are congruent by SAS rule. Therefore what? AB is equal to BC. Now as we have proved here that AB is equal to CD and AD is equal to BC, so we can write AB is equal to what? CD, and BC is equal to AD. Now if AB is equal to BC and BC is equal to AD and AB is equal to CD, we can now write that all the four sides of the parallelogram are equal, and hence it is a rhombus. Okay, as I told you children that this is a lengthy proof, so you have to pay attention carefully. So when you will go through my video, See that you pay attention to each and every part and don't lose your connectivity here and there. So first we consider the two triangles, we prove them to be congruent. Then we prove that these lines are parallel. Then we can also prove that AB is parallel to CD. Okay, and we can now write that ABCD is a parallelogram. After proving that ABCD is a parallelogram, we will then consider these two triangles, the adjacent triangles, and then we prove them to be congruent by SAS. And then we apply that if AD is equal to BC and AB is equal to CD, and we now get AB is equal to BC and CPCT. Considering the three parts, we will now take all the four sides to be equal, and we can then write that ABCD is a rhombus. Okay, so I hope this is clear to you. From this point, since AB is equal to CD and AD is equal to BC, we have actually got AB is equal to BC. So AB is equal to CD, BC is equal to AD, and so all the four sides are equal. Similarly, we have one more question, fourth one. So I'll see that also and I will explain that also and finish off. Question 4 says that in a square, you read your question from the book. If the diagonals of the square are equal and they bisect each other at right angles. So you have to show that in a square the diagonals are equal and they bisect each other at right angles. Okay, so therefore I have to draw a figure, fourth one, a square A, B, C, D. Draw this and this is O. Now diagonals of the square are equal, so what do we have to prove? That AC is equal to BD. This is what we have to prove. Okay, then it is also saying that they bisect each other at right angles. So we have to prove three parts over here, children. OA is equal to OC, OB is equal to OD. This is second part. And you know what is the third part we have to prove? That angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA, and all the four angles are equal to 90 degree. So total we have to prove three parts over here. Okay, so we have to consider, we have to take the triangles in such a way that we get three three proofs we can complete. Now what is given? Given is ABCD is a square, and what? Angle A is equal to angle B is equal to angle C is equal to angle D. All four angles are much? 90 degree. That means each angle in a square is 90 degree. And we also know that AB is equal to BC is equal to CD is equal to DA. Now proof. Now first point, AC and BD. So let us consider the two triangles in such a way that we get the first part. That means we have to consider the two triangles in such a way that we get AC and BD. So which two triangles will we take? Let us take ABC and triangle, this one, BDC. Yes, if we prove that the two triangles are congruent, we can then prove that AC is equal to BD by CPCT. So I hope the first point what I have explained you is clear. Let us start with AB is equal to BC. Yes, because it is a square. Then in the second part we will now write angle B is equal to angle C because it is a 90 degree as it is a square. Now the third part is BC. BC is equal to BC, which is a common side. Now children, I know that you have studied congruence in class 7th, and when you will study, even if we have done the previous chapter on congruence, so as many questions you will do and practice, you will be able to understand I mean, you'll be able to be thorough with that topic, congruence. So AB is equal to BC. BC is a 1 minute. No, we will not take BC here. 1 minute. We take AB. AB is equal to CD. Okay, 1 minute. This I will change. AB is equal to CD. Opposite sides of the square means the sides are equal. B is equal to C 90 degree and BC is equal to BC common. We cannot take BC twice. So therefore triangles are congruent by which rule? Side, side and angle. That means SAS rule. Okay. Now according to the SAS rule, means after completing the SAS rule, we can now write that AC is equal to BD. And why? Because CP CT. I hope this is clear to you. First part complete, and we will next prove that these parts are equal. Let us see which two triangles we'll consider. We will now consider triangle AOB, yes, and triangle COD. Okay. Now if I take the two triangles to be congruent, AOB and COD. AOB and COD. Okay. Now let us take, I'll mark these angles. 1, this has 2, this has 3, and this has 4. Now, if you consider these two triangles, children, you can say that angle 1 is equal to angle 4. Yes. Why? Because they are alternate interior angles. And why? Because these sides are equal. It means, you know that square is a parallelogram. So these sides are what? Equal and parallel. So therefore 1 is equal to 4 and angle 2 is equal to angle 3. Which type of angles are these? And these are alternate interior angles. And what is the third point you can consider? We can consider AB is equal to CD. Yes, we can consider AB is equal to CD. Now you know that we've got two angles and one side. So therefore, the triangles are congruent by ASA rule. Now, we will now write, after proving them to be congruent, we can now write OA is equal to OC, yes, and OB is equal to OD, which is CPCT. Now this is first part complete. Now second part also complete. Now we know that we have to prove just one more part, which says that we have to prove one angle to be 90 degree, means they all bisect each other at 90 degree at right angles. So now which two angles are equal? This is what, let us take angle AOB. Okay, now for 1 minute, let us take triangle AOB and triangle BOC, not angle, triangle, to prove the third part. Now we know that these two, OA is equal to OC, yes, this is already proved above, and OA is equal to OC, right? What is a common side? 1 minute, which AOB and BOC. Okay, now OA is equal to OC, which is already proved, and OB is equal to OB common, yes, and AB is equal to BC because of the four sides of the square are equal. So therefore children, I hope you understood that in triangle AOB, this one and this one, the triangles are congruent by which rule? SSS. Okay, now SSS rule we have applied over here, and now these two angles are equal. Okay, by CPCT. Now what are the names of these two angles? AOB. Okay, AOB, just quickly we'll finish. angle AOB is equal to angle BOC. Now you know that this line, this forms a linear pair. Okay, so angle AOB plus angle BOC is equal to 180 degree. And what is this? Forming a linear pair. The two angles are equal. Okay, the two angles are equal. Angle AOB plus angle AOB equals to 180 degree. Twice angle AOB is equal to 180. Angle AOB is equal to 90 degree. So we have now proved that angle AOB is equal to 90 degree. Now this angle is equal to this angle, so this will also be 90 degree. This angle is equal to this angle because of the vertically opposite angles. And then this one BOC will be equal to AOD sorry, which is again a 90 degree angle. So therefore this completes the proof, and in the end we write all the three proofs that yes, AC is equal to BD, OA is equal to OC, and so on. First part, I mean three consecutive congruence parts, congruent conditions we have to take, and we have to prove the triangles to be congruent, and then we have to prove these accordingly. So what you do, children, you will go through this explanation. If you have any doubt, you can ask me. Okay, and complete all your previous work. Thank you. Have a good day.